Hi everyone, welcome back. In today's video, we are going to cover a concept called subnet, right? Subnet. So as the name suggests, it's nothing but a division of a network, subnetwork, right? So in the internet, we know that all the computers have a logical IP address. If you haven't looked at how internet works video, you can watch it. So in that I would have explained like why every computer needs an address, and using that only the computers can communicate with each other. So also in another video I have explained what is public IP and private IP. Just to recall, so all the devices in your home, for example, this can be your personal computer, this can be your sibling's laptop, and this can be your mom's Alexa, for example. So each of them need to reach out to the internet, but you don't want any computer or a mobile phone in the internet to come and take the information from you. So usually what happens in the internet is only the Wi-Fi router has a public IP or a public address, and all these devices will be assigned a private IP. So why this is the setup and why it is efficient and all those things, you can refer to that video. It's a small video only, but you can get a lot of information on why we differentiate the computers which needs to be accessed in the internet with public IP, and in the private devices as the private IP. So you can take this as a separate network, like it on its own is a separate network. So a Wi-Fi router has access to it, right? So now where subnet comes into picture is how an IP address looks, or the range, how the range looks like. So IP address looks like this. The format is dot 255 dot 255 dot 255. So this is how the format looks like: 3 numbers dot 3 numbers dot 3 numbers dot 3 numbers. Why I have denoted by 255 is in each section the maximum number is 255 and the minimum number is 0. So these are the total number of IP addresses that are available in the space. These are called IPv4 addresses. And to differentiate between addresses in the internet and the private addresses, so there is a governing body which takes care of it, which I have explained in that video as well, which is called IANA. So what they decided is that, okay, we will give a range of this to the private IP, so that all the private networks, so like your Wi-Fi router, there are going to be hundreds or thousands of Wi-Fi router. So for all these things there can be a private network behind the scenes. You can take it as each house will have a private network. So they told that certain ranges you can have it for private IPs, and we won't touch that in providing that to the computers in the internet. Computers in the internet can be Google server, WhatsApp server, your Wi-Fi router. So these guys are in the internet. So certain range, for example 192.168.1.0. So one of the range is this 192.168, and after that whatever it comes, this will not be assigned to any computer in the internet. It is always for the use of private devices. So each private network can have this range of IP addresses in it. So you can assign 192.168.1.0 to this device, and 1 to this device, 2 to this device. So this is your house setup, which is small. And then when you go into an organization, so you have multiple departments. So what happens in that is that, okay, a branch comes and says, or a networking guy comes and says, hey, you can assign all the address from the range 192.168.1 to 0 to 1.255. So I am giving you 256 addresses for your organization. So you can use these 256 addresses for your organization. So your organization has, say for example, 4 branches: IT department, sales, HR, and probably a finance department. So now, as a guy who manages the IP network within your organization, you know that 256 addresses are there. If you go and give all the 256 addresses to randomly to everyone, there can be a possibility that the IP gets wasted. For example, the sales computer might need only, for example, 64 addresses, but then when you give them the entire range, they might not be able to accommodate all the IP addresses, and the allocation might not be efficient. So what they do is, so they divide this 255 into subnets. So for example, from 1.0 to 1.64 can be a subnet, and from 64 to 128 can be a subnet, from 128 to 192 can be a subnet, and 192 to 256 can be a subnet. So this particular range which you have been allocated, you are dividing it into 4 so that you can give that subnetwork alone to your respective branches. So you go and say sales, hey, you get from 1.0 to 1.64. So if the sales have 5 employee computers and one big server which stores all the sales information, and the employees can take the sales data. Similarly, you have a same few HR employee computers and a big HR server which has all the HR information. So why we divide this into subnet is, as one thing I mentioned, is it is easier to allocate to different branches. So the first advantage is IP allocation is easier. Second one is routing efficiency. So what I mean by routing efficiency is, so if you know that all the sales computer will only fall in this IP range, so the first advantage is that this router maintains a table. For example, someone from the outside came and asked you for the previous year's sales data. So the Wi-Fi router needs to know where to get the sales data. So in the routing table, it will have the information to reach to a server of the sales. If it knows that this all these sales computer belong to a subnet, it is easier for it to maintain this routing table. So it has a table on how to reach to all the devices, and if it knows that this is how it has been framed, it is easier to maintain this routing table, and it can route the request faster to that respective devices. And also within the each of the subnets, for example, HR system, employee in a HR very rarely goes to get a sales information, very rarely goes to get a finance information. So if it knows that all the computers are within this subnet, for getting some networking information, it needs to communicate to all the devices. For that, at the networking basic level, it sends information to all the devices in its network to ask for certain details. So instead of sending to all these computers, which it doesn't worry about, it can send only to these 4 or 5 devices, which will make the traffic in the network much simpler. If it has to send the details to all the system, even though it doesn't care about these devices, because it is in the same network, it will be costly, as well as the traffic will be always high within your private network. So the second is routing efficiency. The third one is policy application. By policy application, what I means is, so if they are in the same network, it will be hard for you to set up a policy saying that, hey, a salesperson can never come and access the HR server, because HR server contains personal information about the employees, and a sales guy or a sales employee doesn't have any need to come and get that information. So if it is all sitting within the same network, it is very hard to establish that policy to say, hey, don't let anyone come into this network or this computer. But here, since you have separated the subnet, you can just apply a policy here saying that, hey, don't let anyone except the HR person to access the server data, right? So it is easier this way to apply policies. And also, say someone comes to your house or your company and he's a guest, or he or she is a guest, and they want to access the internet. So in this case, all you need to give access to them is the Wi-Fi. They don't need to access any of your IT information, sales information, or HR information, or finance information. So these kind of policies you can apply easier if they are grouped into subnets. So these are the three main reasons. You are given an IP range, and it is little bit efficient for you to allocate it to different departments, and by doing it you make the routing also efficient, because each device has less number of devices to establish communication with, and also the routing table also knows for a particular device how fast it can reach. It will first go and, for example, hit the subnet, and from the subnet it can easily travel through to the requested computer. And the third one is policy application. You definitely will have use cases where you want to apply policies, say stricter policies to HR and finance, and little bit lenient policies to IT and sales, because anyone can go and access the sales info to understand how the company is performing. Anyone will have to go and reach the IT's computer to know how to resolve some issues that is happening in their computer, right? So this is how you can group them into subnets, and these three things are enabled for you. Yeah, let me know if you have any questions, and I'll also try to cover something called CIDR. So CIDR is a way to represent the subnets. So using CIDR, if you see the representation, you will definitely know, okay, on seeing that representation, what range of addresses is assigned to me. So it has made a lot of things easier. I'll explain to you in another video. Thank you. Bye.